Okay, I am here in Northern California at home where objects like this air quality meter and this respirator have sadly become pretty common household objects. The fires have been raging in California, in the West more broadly, for many weeks and destroying homes and people's lives and ruining the air quality for the rest of us in the process. Which is what led me to the company we're going to talk about today, which is called Salo Sciences. The CEO is a gentleman named David Marvin. What this company is trying to do is apply satellite imagery, computer vision technology, and algorithms, and just hardcore cloud computing data crunching to give us a much better idea of the health of our forests and whether they may pose a fire risk in specific regions. In the bigger picture, the idea is that this technology could be used to really take care of our forest better and reduce the risks of fires and other climate problems moving forward. So with that, let's head to Salo Sciences and figure out how their technology works. Well, tell me a little bit about the background of this company and what you guys are up to.
So Salo Sciences is a conservation technology company. My co-founder, Chris Anderson, and I, we both come from academia. We're both forest ecologists by training. And we both met at a lab where we saw the need to be bringing cutting edge technology and science out of the academic realm and operationalizing it for organizations that are working to scale up what's called nature-based solutions to climate change. And so these are activities like reforestation or forest restoration, land conservation, really anything that leaves more carbon on the Earth's landscape than lets it back into the atmosphere. We're trying to build the tools and solutions that let governments or nonprofits or even corporations who are trying to implement these solutions at scale that can really help make a meaningful difference in the fight against climate change. So we just launched the Forest Observatory a month ago. This is our first trip to the field to do this, and we'll want to come out here much more times over the next year across different parts of California to do the validation. What you're seeing here is U.S. Forest Service land in the Tahoe National Forest that was thinned recently. If you were to instead leave it in its previous state, where you had dense trees growing near each other, much smaller, branches much lower to the ground, what would happen as a fire burned through, it could begin catching on the lower branches, catching on the smaller trees, and begin laddering up into the canopy of these trees. And once that happens, the fire can jump from crown to crown and become catastrophic, killing off a lot of the trees and causing a lot of damage to the forest. This is a really dense forest stand that probably pre-thinning would be this entire area. So the trees are much closer together. They're smaller in diameter for the most part. You see a lot of understory buildup of what we call ladder fuels. What we're trying to do with the Forest Observatory is be able to map over the entire state all the areas that are still in this kind of really dense, highly stocked state. From there, the Forest Service, State of California, private landowners can begin planning how to restore the forest back to a fire-resilient state.
You know, one of the areas I've been tracking for a long time, or for a decent amount of time, is using satellite imagery as sort of like this accounting system of the earth. You know, we can track deforestation now. We can like literally kind of make counts of all the trees on the planet and how these things are changing. I know you guys use some of these tools, but I mean, I have to assume for this type of work, the advances in technology that have taken place over the last 5 years is kind of like what's opening up this opportunity to modernize how this type of stuff gets done.
We see there's three key advances in the last decade or so that has really allowed us to exist as a company. And allowed a lot of really amazing scientists to do a lot of great work at the scale of the entire Earth. These are the advent of satellite constellations, those like Planet Labs and Capella Space that are launching these really amazing high-res sensors that capture the entire surface of the Earth every day, combined with really cheap cloud computing. So to process the insane amounts of data coming down from space every day, you've got to have a lot of computers and you got to be pretty cheap to run those. And then the third major advance is really artificial intelligence and the different kind of branches of AI that are now out there. We're mostly working with what's called deep learning. And this is a really great technology that allows you to extract really subtle, complex, multidimensional patterns from these satellite images and turn them into information that's really valuable. And in our case, this is patterns of ecological attributes or ecological change that we can use to understand our Earth in a much better way.
And just to kind of help make this clear for people, I mean, give me like one or two very specific examples of projects that you guys have done.
We just released our first major product. This is called the California Forest Observatory. And so this is a system we built with all those tools I just mentioned, cloud computing, high-res satellite imagery, and deep learning, to be able to map all of California's lands in high resolution in the current year and do this over time. So we can begin monitoring how the landscapes of California are changing. And we did this specifically in the context of wildfire. So California, as many folks are aware, is going through an extraordinary wildfire season right now. We're just halfway through, and we've already burned more than 4 million acres of land. Now, not all of that is destructive and catastrophic fire. A lot of that is fire we need to have on the landscape. But there are a lot of areas that have experienced catastrophic mega fires that have burned homes, destroyed communities. We're trying to be able to build a system, and we have released a system that lets us understand the fuels buildup across California to get a better sense of where future wildfires might get out of control, and more importantly, where to go and do the restoration work across California to reduce the potential for those wildfires to make a catastrophic impact on our natural resources and our communities of the state.
If you try to build one of these models, I mean, so you guys have focused on California so far. So if like Australia comes to you and they say we want a model, for the entire country, what would that entail for you guys, and like how long would it take to build something that was fairly detailed?
One of the great things about this technology, deep learning, it takes a lot of time and energy and money to be able to train these algorithms to the point where they can recognize things like the height of trees and satellite images. Once you've done that, it's learned the basic patterns in the satellite imagery that can relate to the height of that tree. And there isn't such variation in trees and in imagery to the point where if you were to take a trained model in California and apply it to a forest in Australia, it will start predicting like negative tree height or something, right? It's going to generally recognize what it means to be a tall tree. So all you have to do at that point is then tweak it just a little bit more, transfer the knowledge that you had in California and tweak it to work in Australia.
It still seems like you're optimistic about, that this sort of technology actually can make a significant difference, not just like in 50, 100 years. I mean, the way you were talking, it sounds like, we could actually use this practically in the next 2, 5, 10 years to have some significant effect on things.
So yes, I'm optimistic that, the technology can play a role, but it really doesn't work without the policy to implement the technology. It doesn't work without the funding that we need to do the actual work on the ground. Just because we're experiencing a once-in-a-lifetime pandemic that, is destroying a lot of budgets around the country doesn't mean we don't have to still think about the larger problem of climate change. That isn't going away. And as we saw from the decline in emissions during the early parts of the lockdown, even stopping driving cars and not going to work anymore only caused a small blip in our emissions. There's much bigger systemic changes that have to occur globally for us to really tackle this issue. And it's not going to be a simple decision that we can each take. It's going to be a collective decision across nations, across communities, and we've got to start working on that now. But I do think we can do it.